All right, problem number 9. So we are being asked to find the slope of the line that would be parallel and perpendicular to the line that runs through these 2 points. So they're giving me x1 and y1 here with this first point. And they're giving me x2 and y2 with the second point. We need to find the slope that goes through those 2 points. So our formula for slope is rise over run. Rise is my y-axis, so that's y2 minus y1. Over my run, that's my x direction, x2 minus x1. Then we substitute in, so y2, that's -2, minus y1, that's -14, over x2, that's 5, minus x1, -3. When I subtract a negative, like I'm doing here in the numerator and I'm doing in the denominator, that's going to turn into addition. So that would be -2 plus 14 and 5 plus 3. -2 plus 14, that's 12. 5 plus 3 is 8. If I do 12 divided by 8 in my calculator, I don't get a whole number. So I need to reduce this fraction. What will go into both 12 and 8? 4. So I'm going to divide both top and bottom by 4 to reduce my fraction down. So that would be 3 over 2. So there's the slope of the line that I was given. How would I find the slope for the parallel line? It's going to be the same slope. So this is also going to be 3 over 2. Perpendicular slope how do I find perpendicular slope? Yes, reciprocal. So I flip my slope over. So instead of 3 over 2, it's 2 over 3. And change the sign. So -2 over 3. What else would you guys like to see off of this review? You said number 2? Absolutely. All right, so on problem number 2, we were told that line P is parallel to line Q. And we were told that line M is parallel to line N. So that means that as I'm looking at alternate interior angles, alternate exterior angles, corresponding angles, these will be congruent. They also told me that the measurement of angle 16 is 74 degrees. So this right here is 74 degrees. I'm going to go through and mark on the picture every other angle that would have to be congruent to that 74 degrees. Well, angle 14 is a vertical angle. So angle 14 would be 74 degrees. 16 and 12 are corresponding angles. Lower left corner. So they are going to be congruent because corresponding angles are congruent when my lines are parallel. 16 and 10 are alternate interior angles, and those are congruent when my lines are parallel. So that would also be 74 degrees. 16 and 2 are alternate interior angles. So those would be congruent. 16 and 4 are corresponding angles. So those would be congruent. To look down here at angles 5, 6, 7, and 8, I can't make relationships to angle 16 because they don't have any transversals in common. But I can look at what I've said over here. 16 and 12 are congruent because they're corresponding. Well, 12 and 6 are alternate interior angles. So since I know that angle 12 is 74 degrees, the alternate interior angle, angle 6, would also be 74 degrees. Angle 12 is a corresponding angle to angle 8. So that one would also be 74 degrees. So because I've got two sets of parallel lines, I have a lot of congruent angles here. Part B, measurement of angle 4. That's one of the ones that we marked as congruent because it's a corresponding angle to 16. So angle 4 is 74 degrees. Angles 4 and 8 are corresponding angles. So since 4 is 74 degrees, that means 8 also has to be 74 degrees. Angle 11 is not one of the ones that I've marked as congruent to angle 16. 12 is congruent to 16 because those are corresponding angles. What would I call angles 11 and 12? They're side by side like this. It's a linear pair. Angle 11 and 12 are a linear pair. And linear pair angles are supplementary. Which means the measurement of angle 11 plus the measurement of angle 12 equals 180 degrees. And we know because angle 12 is a corresponding angle to 16 that it is 74 degrees. So if I subtract 74 degrees from both sides, what is 180 minus 74? 106. We still need to find angle 3. Well, if I come over here to angle 3 and angle 4 are side by side, just like angles 11 and 12 were. So these would also be a linear pair. Since they're a linear pair, they are supplementary. So the measurement of angle 3 plus the measurement of angle 4 would be 180. I don't need to solve that all over again. If angle 4 is 70 degrees and together angle 3 and 4 add up to 180, how big would angle 3 have to be? 106. Solved the exact same way we found angle 11. What else would you guys like to see? Number 10, absolutely. So number 10 says we are given the line y equals 1/3 x minus 6. It doesn't tell us that we have to graph that line, but I want to graph it just for practice so that the other two parts make more sense to us. -6 is my y-intercept, so if I'm graphing this line, I'm going to go put -6 on the y-axis first. And then 1/3 is my slope. The numerator 1, that's my rise, so that's telling me I'm going to go up 1. The denominator 3, that's my run. Since it's positive, I'm going to go to the right 3. So from that point that I put on the y-axis, I'm going to go up 1 and right 3, up 1 and right 3. And I think I can go backwards a little bit too. Down 1 and left 3, down 1 and left 3. Do everything in reverse. And then I would grab my straight edge and draw through those points. So here's that original line they gave us. We didn't have to put that part on there, but that's going to help me make sure that I did my parallel line correctly. So I want my parallel line to go through this point. So I'm going to plot that point first, -4, 2, right here. Talk to me about parallel slope. How do I find parallel slope? Whatever the slope was of my original given line. What was the slope of my original line? 1/3. So my parallel slope is also going to be 1/3 because it will be the same slope. So from that yellow point that I put down, I'm going to rise 1, so up 1, and I'm going to run 3, so to the right 3. So yellow dot, up 1, right 3, up 1, right 3, up 1, right 3, up 1, right 3. And I can go backwards 1, down 1, left 3. Grab my straight edge, trace through my points. Does that look parallel? Does that look like railroad tracks with that original line? Yes, so I know I did this one correctly. For part B, I want it to go through this point this time, 1, 6. So I'm going to go and plot that point. 1, 6, right here. And I don't want this one to be parallel. I want this one to be perpendicular. How do I find perpendicular slope? Flip it and change the sign. So reciprocal and opposite sign. So when I flip 1/3 over, I get what? 3/1. And then we have to change the sign, so it has to be a negative. I have to decide whether that negative is going to go with my numerator or denominator. It won't go with both. You put it with one only because there's only one negative sign. I always put it with my numerator. I take care of that with the rise. So my numerator is -3, which means I'm going to go down 3. Since I put the negative sign with my numerator, my denominator is a +1. This is my run. Since it's positive, I'm going to run to the right 1. If the numerator is positive, you rise up. If the numerator is negative, you rise down. If the denominator is positive, you run to the right. If you had decided to put the negative sign with the denominator, when the denominator is negative, you run to the left. All right, so from that red point that I plotted, I'm going to go down 3 and right 1. 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 And that's as far as I can go in either direction. So at this point, I would grab my straight edge and trace through those points. So here's my perpendicular line. When you look really closely right here, it should look like a plus sign. If you tip your page, it should really look like it is a right angle right there. Sometimes when they're slanted, it's a little bit hard to see. But if you tip the page so that it makes this flat across the bottom, this will look like it's going straight up and down. You should notice the exact same thing right up here. That should be forming a right angle there if it really is perpendicular. What else would you guys like to see off the review? Yes. Number 5? Absolutely. All right, on number 5, it says my given is that angle 1 is congruent to angle 8. So my first reason is because it has been given. I'm going to go ahead and mark that on my paper. Angle 1 is congruent to angle 8. Looking right down here, can you guys tell me another angle that's the same size as angle 8? Angle 5. Why? They are vertical angles. So angle 8 is congruent to angle 5. They are vertical angles, so I'm using my vertical angles theorem. Well, if 1 is congruent to 8 and 8 is congruent to 5, what else could I say? Angle 1 is congruent to angle 5. What am I using to be able to say that? Transitive property. Since we're working with congruences, it needs to be transitive property. We replaced one entire side of our congruence with something else completely. So transitive property gets used specifically in 2 places. One, it's when I take everything either before or after an equal sign and I replace it with something else. Everything on that side, not just a piece. And I have to use transitive property when it's congruences in that. All right. Let's go look at this picture. We said angles 1 and 5 are congruent. What would we give, what name would we give this angle pair, angle 1 and angle 5? Let's see, the transversal that is connecting them would be line T. Are they on the same side or opposite sides of that transversal? Same side. What's the 2 lines that T is crossing? J and K. Are angles 1 and 5 in between J and K? One of them is, but the other one isn't. So they're not both interior. So I can't call them interior angles. Are they both exterior to J and K? So I can't call them exterior angles. Are they in matching corners? Yes. Upper left-hand corner, upper left-hand corner. What do we call the angle pairs that are in matching corners? Corresponding angles. And we already established that these corresponding angles are congruent. When my corresponding angles are congruent, we're going to use the corresponding angle theorem converse. The converse says I know my angles are congruent, and so that means the lines, in this case J and K, have to be parallel. My converse theorems are always when I'm making a statement about lines being parallel. If I am given that lines are parallel, then I'm not going to use a converse. If I'm being asked to prove that lines are parallel, then I am using a converse. What else would you guys like to see? Number 8, absolutely. All right, so, oh wait. You want this number 8 or the unnumbered number 8? That one? Okay, sorry, I just realized that there was an unnumbered problem on here. It comes after 7 and before 8, somehow. All right, so my first statement is going to be my given information. J is parallel to K. My reason for that is because it's given. So I'm going to come over here and mark it on my picture. Because I already know that the lines are parallel, this is not one where I'm going to use a converse. All right, then we have this statement that angle 1 is congruent to angle 5. What would we call that angle pair? Corresponding angles. So because I know the lines are parallel, these corresponding angles are congruent by my corresponding angles theorem, not the converse. Why would I be allowed to say that angles 5 and 6 are supplementary? Yes, they're a linear pair. They are side by side. They are a linear pair. And a linear pair is always supplementary. So because angle 5 and angle 6 are a linear pair, we are using our linear pair theorem. All right, so I know that angle 1 and angle 5 are the same size. I know that angle 5 and angle 6 add up to 180. They're supplementary. I'm supposed to prove that angle 1 and angle 6 are supplementary. So since that's what I'm supposed to prove, that's going to be my last statement. Angle 1 and angle 6 are supplementary. Now I want to figure out why I'm allowed to say that. I know that 1 and 5 are the same size. I know that 5 and 6 are supplementary. So why would I be allowed to replace angle 5 with angle 1? Substitution. This is substitution and not transitive because I'm not replacing everything on one side of an equal sign. I'm just replacing one little piece here. So this is substitution property. What else would you guys like to see? 13? Absolutely. Name the following pairs of angles, if possible, and describe their relationship, congruent or supplementary. So first one they give me is 10 and 11. What's the transversal that's connecting those? M. Are these on the same side or opposite sides of that transversal M? Same side. They're both on top of line M. What are the two lines that M is crossing? S and T. Are 10 and 11 interior or exterior to S and T? Interior. So these are same side. What word do we have for same side? Consecutive. These would be consecutive interior angles. Are those congruent or supplementary? Supplementary. All right, part B. 6 and 14. Here's angle 6. Here's angle 14. What's the transversal that's connecting those two? S. Same side or opposite sides of that transversal? Same side. They're both on the right. What are the two lines that S is crossing? L and M. Are 6 and 14 both interior to L and M? Are they both exterior to L and M? Are they in matching corners? So what would we call them? Corresponding angles. When they are on the same side of the transversal, they're either both going to be interior, so consecutive interior, they're both going to be exterior, so consecutive exterior, or we're going to have one of each, same side of the transversal, but one interior, one exterior, matching corners, corresponding. Those are the only possibilities. Are corresponding angles congruent or supplementary? Congruent. What are the only three that I have that are supplementary? Linear pair, consecutive interior, consecutive exterior. So same side interior, same side exterior, or a linear pair. Those are the only ones that we've talked about that are supplementary. All right, 16 and 3. 16 is here. 3 is here. What's the transversal that connects them? T. Same side or opposite sides of the transversal? Opposite sides of the transversal. What word do we use when they're on opposite sides? Alternate. So it's alternate something. What are the two lines that the transversal T is crossing? L and M. So here's L, here's M. Are 3 and 16 in between L and M? No. So would they be interior or exterior? Exterior, alternate exterior angles. Are alternate exterior angles congruent or supplementary? They are congruent. All right, 15 and 11. 15 is right here. 11 is right here. What do you notice about those two angles? They do have a name. They are side by side, right? They are right next to each other. They share this side right here. And together they make this straight line right here. What do we call that when they're side by side? Linear pair. A linear pair and vertical angles. I only need two lines crossing. Linear pair is going to be side by side. Vertical angles will be where two lines cross and they're across from each other. Linear pair, supplementary or congruent? Supplementary. Three and 16. I feel like we looked at this one already. 3 and 16. Did we talk about that one already? What did we say those were? Alternate exterior angles. We did that right there. So those would be congruent. All right, 6 and 9. 6 is here. 9 is here. What's the transversal connecting them? S. Same side or opposite sides of S? Opposite sides. And what word do we use for opposite sides? Alternate. What are the two lines that S is crossing? L and M. Are these two angles interior or exterior to L and M? Interior. So alternate interior angles. Congruent or supplementary? Congruent. My consecutives are supplementary and my linear pair is supplementary. All right, last one, 4 and 7. Here's angle 4. Here's angle 7. What do you notice about angle 4 and angle 7? They're vertical angles. They're bunched together. I only have 2 lines that are crossing there. Those are vertical angles. Vertical angles, congruent or supplementary? Congruent. Nice work. What else would you guys like to see? Number 12, sounds good. Write 2 equations in slope-intercept form. What is slope-intercept form? So slope-intercept form is this one right here. Point slope is the y minus y1 equals m times x minus x1. But I want my answers to be in slope-intercept form. One of them is going to be parallel to the line that they gave me, so same slope. The other one is going to be perpendicular to the line that they gave me, so opposite sign and reciprocal slope. And then over here is the line that they gave me. Here is the slope of the line that they gave me. So for parallel, the slope is going to be 4/3. For perpendicular, the slope has to be reciprocal, so flip it over, 3/4, and opposite sign, so negative 3/4. We want both of these lines to go through the same point. We want them to go through negative 24/10, so there's my x1 and my y1. So I need point slope form, which I will give you on the test. You have to know how to use it, but I do give you that formula on the test. We're going to use that for both of these. And the only thing that's going to be different is the slope that I put in. So I have y minus, what's my y1? 10. So y minus 10 equals, what do I put in for m for the parallel? 4/3. And then parentheses, x minus, what's my x1? Negative 24. Be careful there. We are subtracting a negative here. So that's going to turn into addition. So I have y minus 10 equals 4/3 times x plus 24. I need to take this 4/3 and distribute it. I'm going to bring my work over here. Y minus 10 equals, and then I have 4/3 x plus, and I need somebody to grab a calculator for me. What is 4/3 times 24? You said what? It's going to be a positive 32, because remember that I had minus negative, so that turned to a plus. And I have a positive 4/3. So plus 32. Add 10 to both sides. So slope-intercept form for my parallel line would be y equals 4/3 x plus 42. For my perpendicular line, I follow almost the exact same pattern. It's going to be y minus, my y1 didn't change, so it's still y minus 10 equals, here's where the difference happens. What do I put in for m now? Negative 3/4. X minus, my x1 is still negative 24. So I still have this minus a negative right in here, so that's going to turn into a plus. So y minus 10 equals negative 3/4 times x plus 24. Taking that negative 3/4 and distributing it. So y minus 10 equals negative 3/4 x, and then what is negative 3/4 times 24? Negative 18, so minus 18 back here. Add 10 to both sides. I have y equals negative 3/4 x minus 8. So there's my perpendicular line. Y equals negative 3/4 x minus 8. All right, we have 6 more minutes. That's time for 1 or 2 more, depending on how long the problems are. What else did you guys? Number 6, absolutely. All right. So they give me the measurement of angle B as x plus 47 degrees. So I'm going to put that right here. They give me the measurement of angle E as 3x minus 11 degrees. This right here is the transversal connecting these two. They're on opposite sides of the transversal, but one is exterior and one is interior. I don't have a name for this pair. So I have to find another relationship. Yes. C. Yes. C and B are the same size because those are vertical angles. So this would also be x plus 47 degrees. So I've got measurement of angle B is equal to the measurement of angle C. And now I do have a name for this pair. What do we call those? Not corresponding. They are both interior. Corresponding would be matching corners. Consecutive interior. Consecutive interior angles, congruent or supplementary? Supplementary. So that means the measurement of angle C plus the measurement of angle E equals 180. We said angle C is the same size as angle B, so that becomes the measurement of angle B plus the measurement of angle E equals 180. So x plus 47 plus 3x minus 11 equals 180. I combine my like terms, x and 3x together to get 4x. And then I have the like terms of positive 47 minus 11. So that would give me plus 36 equals 180. I subtract 36 from both sides. So 4x equals 144. I divide both sides by 4. And I get x is 36. No degrees symbol on that because x is not an angle all by itself. Then they asked me to find the measurement of angle F and the measurement of angle H. Well, F is a corresponding angle with angle B. And those are congruent. So angle F is congruent to angle B. So the measurement of angle F is equal to the measurement of angle B. So x plus 47, we just found out that x is 36. So 36 plus 47, measurement of angle F is 83 degrees. To find H, that is a vertical angle with E. And vertical angles are congruent. So angle H is congruent to angle E. So the measurement of angle H equals the measurement of angle E. 3x minus 11. We just found out that x was 36. 3 times 36 is 108. So the measurement of angle H is 97 degrees. That is not the only ways you could find angles F and angles H, but you do have to find X first. Very quickly before you guys go, I want to show you where you'll be able to find the videos for today and the answer key, which will be posted next period.